All right. Hello, everyone. We should basically start now. Yeah. So welcome to our game hacking workshop. This is a collaboration between Cyber and Studio. Woo! Yeah, and so today we'll be going over Aimbot and Cheat Engine. If you're wondering about Josh, why he's in that corner, well, he's sick today, so even though he's a presenter, yeah, he's just going to be presenting online right now. Uh, there's just one of the challenges we have to face nowadays. Anyways, Josh, next slide, please.
All right, so first, I guess we'll do a little quick introduction on sort of like the history of like cheating and hacking in video games. So the earliest forms of video game hacking were actually implemented by the developers themselves. Often they would be like checkpoints or like cheat codes, which will allow them to make testing the game a lot faster. So one of the most famous cheat codes is called the Konami Code. Um, can someone, I guess, raise their hand and tell me what the Konami code is? And they'll get a free Chick-fil-A gift card. I saw your hand first.
Up, down, down, left, right, DA.
Up, down, left, right,
Right.
DA. Okay. You want this Chick-fil-A gift card?
Technically, DA start.
Yes. Okay. Thank you. Yeah. Okay. Yeah. Next slide. And so after sort of these cheat developer or these codes were put into like video games, then people started essentially creating specific hardware to allow people to cheat games. So this is an example of like cheat cartridges. And essentially that you would plug this into like a device where there's like a Sega Genesis or NES, and you could look at the memory at a specific address and modify the memory at a specific address. And so one of the most, I guess, the simplest form of doing this modification was something called peek and poke. And peek and poke are essentially commands that allow you to look at a specified memory, a specific address in memory, and then modify it. So the language that was used was like BASIC, although Pascal, I think, and some other languages also have this exact instruction, which is peek and poke. And then now that sort of evolved into like debugging and debuggers and other modern forms of like cheat engine or cheat editing software that allow you to directly modify memory. Next slide. And so moving on to the present day, cheating has sort of evolved from just simple modification of memory, especially with the, I guess, the evolution of like multiplayer games. People are trying to find ways to cheat multiplayer games to gain an advantage. One thing is like artificial lag, so otherwise known as a lag switch, where a player will try to manipulate their latency on the client side to fool the server into thinking that, you know, maybe it's too slow or not to gain a competitive advantage. Another thing is like world hacking or extrasensory perception, as shown right here, which essentially like you're able to like see people behind walls and draw an outline to where the enemies are and, you know, see more of the world than you're supposed to. And then there's sort of look ahead where you're abusing like in a peer-to-peer connection. You essentially can see what the other person is doing. So in like a turn-based game, what if you knew the actions the other player would do before they actually made them? And then one of the things that we're going to be covering today is an aimbot slash trigger bot, which essentially is having perfect aim and always making sure that your gun snaps to like an enemy's head.
Next slide.
Yes, Josh.
Oh, you want me? Okay, cool. Okay, yeah. So an example of like some kind of software or cheat that we could use nowadays is something called Cheat Engine. And so what Cheat Engine is it's like a program that you can download that allow you, or it's basically a compiler or decompiler. So basically it'll look at, you could use it to attach. Can you guys hear me okay?
Yeah.
Okay, you can use it to attach to a process or like a game, and it allow you to look at the contents in the memory of that process. And so you know, you could use it to like change some values in the game and just have an advantage in terms of like maybe like have more lives or maybe do more damage, whatever it may be. And you can also use it to inject code, which is a little bit more complicated. But today we're just going to go into the basics of how to use Cheat Engine to you know, change some values. So So yeah, let's go ahead and go into our demo. All right, hello everyone. Let's go ahead and do a demo of using Cheat Engine. So before we start, one thing to note is that Cheat Engine is a memory debugger. And so basically, knowing this, we can use Cheat Engine to open a process. So for example, the game we'll be using is Plants vs. Zombies. And by doing so, we'll be able to access all the memory of Plants vs. Zombies and try to find where certain values are being stored and change it so that we can hack our game. So let's go ahead and do that. So the first thing you want to do is obviously open up Cheat Engine and also the application you want to look into. Then you go ahead and click this monitor looking button on the top left and choose the game that you want to hack. So in this case, we're going to want to do Plants vs. Zombies. Let's go ahead and open it. And so let's go ahead and play our game. And so if you don't know how Plants vs. Zombies work, basically, you make a bunch of plants and you get these like sunshine things and these points, and then you're going to want to kill the zombies, right? So the way of getting the sunshines is, it'll drop, or like these sunflower things will drop. But let's say, for example, instead of waiting for these things to drop it, we just want to have like an unlimited amount of sunflower or limited amount of sun power. So something we could do is using Cheat Engine, we could search through all the values in its memory to look for something with a value of 50, right? Because we know the current value or the current number of sun points we have is 50. So let's go ahead and do that. When we do that, we see that we've narrowed it down to 957 different addresses that have a value of 50. So that's a good start. But let's go ahead and continue playing, right? And now we see that it's increased to 75. So what we can do from here is we can do a next scan, which will basically look through all 957 addresses that is found, and it'll try to find something that matches this new value of 75. So when we click that, we see that there's one single address, and this is most likely referencing this 75 here. So we can go ahead and double click it and add it down here. Let's go ahead and name it sun. Oh, sorry, sun. Let's make it a little bit more clear of what it is. And so knowing this, we can then try to change the value at this address to see if it will change in the game. So we could see like 1500, and voila, we see that it does have a value of 1500. So now we can go ahead and just plant whatever we want, kind of be greedy and generous or whatever. But we see that it's going down, and let's say we want to keep it unlimited. So what we can do is we can just deactivate it. So now changes to this address or you can't change the value at this address. So for example, if we click this, it will just go back to 1200. Okay, awesome. So that's one way to do things. Obviously, it is a little bit easier when there's a set value. So for example, like 1200, 50, 100, all these numbers, right? But many times, there's might be like a cooldown or some value that you don't know the specific number, but a general idea of like whether it's increasing or decreasing. So luckily, Cheat Engine also has these kind of features, right? So instead of looking for an exact value, we could look for an unknown initial value, and then like after we do our first scan, then like if it's increasing or decreasing. So in this game, let's say for example that we want to just remove the entire cooldown of when we're putting a plant down. We just want to make it so that we can just keep putting this plant down. So what we can do is go ahead and just do a new scan, and we'll do an unknown initial value because obviously we don't know the exact value of this bar right here. And we'll do our first scan, and we get 52 million addresses, which is not a great start. But again, we're going to narrow it down. And so what we're going to do is, this bar keeps going up. So let's just say that the value is increasing. So let's go ahead and do that. And then you click next scan, and I narrowed it down to 350,000, which is pretty good, but again, still a lot. And so using cheat engine, you're gonna want to keep on like doing this. It might be a little bit repetitive, but obviously you keep narrowing it down. Right, and okay, and so now we put another one down, and since it used to be at the top, now it's at the bottom, we decrease value, increase value. There's also ones where it just doesn't change. So obviously, like we pause the game, so it should have changed. It'll get rid of some. Again, just kind of repetitive, but this is how we're scanning. 11. Okay, let's see one more. Okay, awesome. So we have 5, and looking at these numbers, they all look pretty look like pretty valid. Any of these 5 could be the ones that we're looking for. Let's see what happens. So at this point, we see that there is no cooldown, or there is no we're allowed to put the plant on, and this value is 0. So that's a possibility. Maybe that means something. So let's try saving that and changing this, or how about we just keep it to 0? So we just deactivate it. So now maybe there won't be a cooldown. But if we look at it, we see that instead it's always just staying down here. It's just not something that we want. So maybe instead of keeping it at 0, we put it to like a really high number, like 1,000, and we just keep it at that. And now we see that this address does correlate to this cooldown thing. And now we can just go ahead using the 2 cheats that we found, just keep putting as many of these plants that we want. And so we could do the same thing for a bunch of these other plants, or for the cooldowns, or just changing values. Maybe we want to change the price from 175 to like 50. We can just do stuff like that. So yeah, that's the basic idea of how to use cheat engine. Can be a little repetitive, but that's just how it works. One other thing I want to note, I'm not going to go too much into detail because it's kind of a little bit more complicated. But if you go into this memory view over here, we can actually look into memory and see where exactly a certain address is. And typically, for a specific thing, like for example, for this ice pea shooter, chances are that most of its values, whether it's the price, the cooldown, or how much damage it does or something, it'll probably be in the same general area. So what you can do is you can actually, once you figure out an address that corresponds to this, let's say it's at this address right here, then what you could do is you could look to different addresses that are really close to see if this changing values here will change anything for this specific play. And so yeah, that's pretty much it. That's how you use cheat engine. Yeah, good luck with your own stuff.
All right. Yeah. So basically, like the video showed, Aimbot is basically where you let the computer aim for you, and you have perfect aim, and you can basically use this in multiplayer games to gain clout or KD. It was okay. Anyway, so like some additional features of this are ESP, or extrasensory perception, where you can like see through walls, and TriggerBot, which is where like you only need to move the mouse, you don't need to click. Yeah. So like I mentioned, ESP is right here, where you can see hidden objects, like for example, people through walls, or like in Fog of War in League, and then TriggerBots, like I mentioned. Yeah. Okay. Anyway, so we're going to discuss 2 different kinds of hacks. So there's an internal versus an external hack. So an internal hack is basically using Dll injection to eject a Dll into the process of the game, and this is harder to detect and better performance, and basically better in almost every way than external hacks. But external hacks just use an external pipeline to access the memory of a process, and because of that, they are harder to execute and also easier to detect. But there's benefits of both. Anyway, so going into some more important concepts that we need for doing the aimbot. So multi-level pointers are basically just pointers that point to pointers that point to pointers. So pretty self-explanatory, and this is often used in games because games often take advantage of like a lot of like object-oriented programming mess. So for example, in this situation, we can have an actor that points to a player, that points to an inventory, that points to an ammo variable or struct with the variable of leet. So yeah, this is also very important for talking about bone matrices because, well, bone matrices are structured similarly, and we will talk about that later. Another important thing we need to talk about are handles. Handles are this Windows API sort of abstraction of a system resource. They are sort of like a pointer. Basically, what you use them with Windows API functions to modify the resource in some way. It's pretty complicated if you think about it, so you shouldn't really think about it. Like Windows doesn't really want you to think about it. So just think of it like just a reference to some resource on the computer. And rounding up the concepts, what is a DLL? Well, DLL is a dynamic link library. If you've taken CS33 like and talked about like the compilation process, this might be a little bit familiar to you, but this is like the Windows version of it. With the DLL, you can use the same code, like the same library code with multiple programs. So you don't bloat up your system hard drive with the same code over and over again. Another thing is that it's also good for modularization. So like if the library developer decides to update the library, then, well, like it updates properly, and the underlying applications that use the library don't have to change anything for it. And DLLs are also useful for unintended consequences, such as our intent of use, Dll injection. So what is Dll injection? It's basically where we force our process, say cscode.exe, we force it to run our own DLL, and we basically gain arbitrary code execution in the address space of another process. There are multiple ways of doing this. In Windows, you can add to the DLLs in the registry key. This registry key asserts DLLs, or we can edit the DLLs in the registry entry. So app.init DLL here, and then basically, if you edit these keys or entries, whenever you load, I believe it's user32.dll, you load basically all the DLLs there, and so in that way, you can load your DLL into some arbitrary process. There's also a third method, which is via like process API functions, and that's what we're going to talk about. So in our DLL injector method, we use the create remote thread Windows API function to basically deal a DLL injection. So the step-by-step process for this is basically once we've gotten the process ID of our target process, say cscode.exe has like a process ID of like 1600 or something, then we call the open process API function on it. This is what gives us our handle for it, basically just converting our process ID to a handle. And then we call this virtual alloc_x function, basically just allocating memory in some external process. We allocate enough memory for our DLL path and in our target process, and then we call the write process memory function, basically just writing our DLL path into our target process. And then finally, we call create remote thread. So a bit more detail about it is that what it does, it runs a thread in the target calling process. So in the namespace of cscode.exe, we would run some function that would load a library into memory. And so through that, because we have our DLL in memory, we can load our target DLL, and we have successfully DLL injected. And here's some sample code. It will also be on the GitHub for the Aimbot boilerplate.
Okay, so that was a lot of background knowledge. And so we want to transition to actually creating an aimbot using Dll injection. And so to actually create the aimbot itself, there are 3 steps. One is we need to find the closest enemy to the player that we're controlling. Second is we need to calculate a vector, right, from the player's view angle. which I'll explain later, to the enemy's head. And then third is we need to rotate the player's view angle to that vector so that we're pointing at the enemy. And so a little bit, so how we're actually going to find like the players, right? Where they are in memory. So there's this concept called the entity list. A lot of engines like to store players, NPCs, right, AI, in this thing called an entity list. And you can sort of think about it as an array of pointers. For CSGO, there's an offset of 16 bytes between each entity pointer. And so how we're actually going to iterate through this is, one, we're going to get the base module address of the client.dll. Essentially, this is the start of the array. And then we add the offset to the entity list in the second line. And then third is we can specify the index. So if I want to get, for example, the third element, right, of the array, the third entity, I would take the base address of the entity list and add the index of 2 because it starts at 0, and then we multiply it by the offset of each entity. And then we return a pointer to that player's string. Another thing we need to explain is the concept of view angles. And so essentially view angles are the angles that are created when I look at something. So for example, if I'm looking straight ahead, the view angle perpendicular, or I guess view angle that's I currently have is 0. Pitch refers to looking up and down like this way. And yaw refers to horizontal, looking like side to side. Pitch is about the x-axis, and it's measured with from negative 90 to 90 degrees. I believe in CSGO, negative 90 means up, and then 90 means down, like looking towards your feet. And then for yaw, it's looking left and right. So negative 180 degrees is left, and 180 degrees is right. One thing you might notice is that the up axis is Z instead of Y. That's something I think specific to Source Engine. I know if you use Unity, the up vector is usually Y. But for all our calculations, we'll be using the Z axis as the up vector. And then so with that, we need to actually find the closest enemy. So we're going to loop through all the players in entity list, explained 2 slides ago. And then we're going to get the position of the player, right? So we're going to get the origin, which I'll explain later. And then third is we're going to calculate the distance from where the player currently is to where the enemy is in the entity list. And so the first one is, I think, pretty self-explanatory. We're just getting the reference to the current player, a pointer. The second is we're doing some C++ magic. Okay, so like what is happening? Right, it's this UN pointer cast, and you dereference this plus adding some. Okay, let's just break it down a little bit. So if you remember, like this pointer refers to the calling, like the function that's the object that's calling the function, right? And it returns a pointer to it. And so what we're doing is we're using a generic pointer, which is UN pointer underscore t, right? Which is a generic 32-bit pointer. We use a 32-bit pointer because CSGO is a 32-bit process, right? So the memory addresses will take 32 bits. And so just to enforce that, we'll pass it as a UN pointer underscore t, right? And then so with this, we're going to dereference that pointer to this. So that will give us the actual address of the function of the player itself. Like because we're calling the function within the game's memory, this will actually give us memory within the CSGO process. So once we have the player's base address, essentially, we just access the offset to one of its member variables, which is in this case vector origin, which is why we add m underscore vec origin. And once we have that offset, we want to cast that as a vector 3 pointer because we know that essentially the vector origin is stored as this type, so we get a pointer to that. And then once we have the position of the player, we have the enemy, we just need to do Pythagorean theorem to calculate just the distance between those 2 points. And so we have that. We need to calculate the view angles, right? Essentially the vector that we need to change our view angles to in order to point to the enemy. And so this is going to deal with the pitch first. We're going to draw a vector right from your head, the player's head, to the enemy's head. So I represented that as alpha, right, with pitch. We're using the degrees. CSGO measures, like actually stores the values, right, of the view angles in degrees. So that's important in terms of units. And the pitch is negative as you look up, right? So negative 9 degrees is when you look up, 9 degrees is when you look down. And so in order to get, let's say the enemy is, some distance above us, we'll use this geometry arcsine z over the hypotenuse to calculate what our view angle alpha should be in order to look at the enemy. So wait, one thing you might notice as well is that there's this view offset from the vector origin. So the vector origin refers to a point that represents the player, and it's only one point at the essentially the bottom of the player's foot, and it's just used to like make calculations of position easier instead of like storing like all the the entire skeleton and using those for every single calculation. The player can be represented as just like a single point. But if we calculated the vector right from the vector origin, we wouldn't have the correct angle. So we have to add this offset from the bottom of the player's feet, essentially to where the camera is facing at the player's head level. And then we just essentially use the same method to find yaw, right? Left and right. We can use arctan for that, y over x. So it's pretty much the same thing. And then now we have the view angles. We need to find a way to actually reference the enemy's head, right? So we can find the position of the head in world space coordinates. And so Jeffrey alluded to this earlier. There's something called the bone matrix. And the bone matrix is essentially like an array of bone objects. And each bone contains like X, Y, Z coordinates representing like a position on the skeleton. And so the picture on the right, you can see there's sort of numbers that represent individual bones. And so these are stored within a matrix. You essentially read a skeleton or parse the skeleton by going through the bone matrix and connecting all the bones. One thing to note about CSGO is that different models have different bone IDs, which correspond to different body parts. But luckily, the bone ID of 8 is the same for all models, and it represents like a model's head. So we can use that. So here's the code that we use in order to get like a position on the bone matrix. And so the first line, essentially, we're getting a pointer or we're actually referencing the bone matrix itself, getting the base address of it. And then we just have a vector 3 that will represent the bone position. And then we get the X, Y, Z coordinates of that bone position. So we're adding this offset, right, of 0x30. Multiplying it by the bone ID and using an additional offset of 12. So why do we do that? Well, the bone matrix is defined as a 3x4 matrix, and it contains 12 float values in total. So in order to reference a specific bone, we have to offset by the size of the matrix first. Then once we have the specific bone position in memory, then we know that those 3 float values correspond to the X, Y, Z coordinates. So 0x0c is offset to the x coordinate, and then we add another 12 bytes, and so on and so forth. So a lot of this stuff is not something we figured out ourselves. It turns out that the source engine is what CSGO uses, right? The whole SDK is online, so on GitHub. So you can check that out and like see how CSGO is implemented, how they do some of these things you want to get more detail. But yeah, just to summarize the steps that we took, we scanned the game, right, to find the closest enemy to the player. Then we calculated the pitch and yaw angles from a player's head to the enemy's head. And then the third thing we did was set the player view angles to the calculated view angles that we we calculate using the Pythagorean theorem. And the fourth is we define a main method, right, in the DLL. So essentially, when we inject, right, our program into the game's memory, it'll run on a separate thread, overriding essentially our player input just to the calculated vector that we wrote in our program.
Okay. So now let's show off the aimbot. Yeah, I guess this is the part where everyone looks up. So right now I've launched CSGO with the insecure flag. Please do not test this without the insecure flag. You get banned. Back ban. Please don't do that. Anyway, yeah. So if you can look here, we have our aimbot code all good and dandy. We have our offsets from yesterday or today, I guess. Never mind. And then we have all our Aimbot code good to go. And you'll see that we'll have a boilerplate of this for you to reference if you want to try this at home. Anyway, so once you launch the game, you can see that. Let's try injecting the Dll. All right, you can see that I can't control my aim, and my pistol is for some reason aiming at something right now. And if you look over here, you can see that it is following this player's head, George. And you can see that even when the elevation changes, say when I'm jumping, it's still tracking his head. Yeah, even when I crouch, even when I'm jumping. And when I go closer to another player, it'll snap to his head. And then if I go to Ulysses, so let's just start killing people. All right, so you can see that I'm very good at CSGO because I just killed everyone instantly. Anyway, but yeah, so you can see that through this demonstration, by manipulating our view angle, we can do some inhuman feats. Or I guess if you're simple, you can just do it yourself. Anyway, yeah, so, all right, let's stop that. And basically, yes, if you follow this boilerplate we have here, you can become simple for just a brief second against hopefully bots. Please don't beat other people with this. Anyway, yeah.
All right, guys, let's hope my computer does not crash again. Sorry about that. Okay, so Peter and Jeff talked about internal aimbot, or internal hacking in general, which is typically better, but I'm gonna talk a little bit about external aimbot, just like what it is. So in case it wasn't obvious, it's called external because we're running an external process rather than injecting something into the game. But honestly, like we kind of talked about, external is kind of whack. Honestly, it's probably better to do internal. The reason is because first of all, it's is usually like more detectable by anti-cheat. And that's because anti-cheat typically will look through all the processes and like maybe like the handles or whatever, and it can detect if there's a handle or if you're trying to access that specific game's memory and stuff like that, like externally. And so it'll be able to detect like well-known hacks that are online, or just like certain like processes or system calls that you might call. Another thing that kind of sucks about external aimbot is there's a lot more math, and it gets a little bit more complicated, which we'll talk about later. Actually, I'm not going to talk about it, but Aaron will talk about it later. And it gets a little nasty, but if you like math, maybe you'll like external aimbot. And the last thing is that it can also be pretty slow, because with external aimbot, you have to do, since we're accessing the memory and changing things externally, we have to do a lot of system calls, which takes up a lot of time, because you have to go through the windows, or you have to go through the operating system to do stuff, the kernel and all that, which is not great in terms of latency. Next slide. So other things, so like I was talking about, you need functions like read process memory and write process memory in order to actually get the game's memory or change it. And you also need the kernel to give you a handle in order to access the process's memory. And like I was saying earlier, the math stuff, there's something called like world to screen translation. If you actually take CS 174A, you actually do some of that kind of stuff. But like I took it last year. I don't remember any of it. I just remember there being a lot of like matrix math. So if you're into that, maybe you'll do that. But yeah, next slide. So in terms of like the general overview of how external aimbot works, first you're gonna want to attach the process. Then pretty similar to internal, you're gonna want to like loop through all of the other enemies, right? And you're gonna want to find the closest one, get the current coordinates, get the head bone of the player, and then some extra math stuff, calculating the world to screen position, calculating like the view angle, like we talked about, and at the very end, firing. Next slide. So the first step, getting that connection, right? You're gonna want to get a handle from the operating system using the open process system call. But you can also use common libraries like nullbase, which will kind of make things a little bit easier. And it probably has like more features, but I think the general idea is in order to do stuff, you first have to get that handle. Next slide. And then, like we were talking about earlier, you're gonna loop through the entity list to find all the enemies, get a bone ID, and calculate a whole bunch of stuff. Next slide. And then finally, hopefully your thing is working and you have all your calculations correct. And all you have to do then is just click your mouse to fire. Yeah.
Okay. So basically, the main difference between like external hacks and internal hacks is that internal hacks you can like specifically set the values of the game and have like the players head or whatever the data is specified. But then for external hacks, like what we're talking about here, what you have to do is you have to basically reverse engineer the mouse inputs that would that would make your character easier to move the head. So it's essentially like you're figuring out what inputs like a robot would need to do in order to move your head in like explicitly set the values. And so yeah, there's a lot of kind of weird math involved, but so I don't want to go too much into it. But essentially, it's basically the same thing as what Peter has been talking about towards internal hacks, which was that you have to, there are different ways that you can basically calculate like sort of pitch and yaw that you would need in order to lock your player's head onto any target. So we can just skip forward up through all the, all that stuff. Any way you want. Regardless, the main idea is that you use some method to find out sort of the angles that you need to rotate your head in order to snap onto the target. Once you know that, once you know these angles, you essentially, okay, now I wish I had a whiteboard, but basically the idea is that, oh, what do you know? Okay. So the idea is that like you have a view angle like this. This is your like field of view, right? So like you can have like an enemy here or something like that. And then that. So this is like your head right here. And essentially what you want to figure out is sort of this angle, what percentage this angle right here takes up out of the entire like maximum angle that you can like move your head in one frame. So these bounds over here represents how far you can essentially turn your head in one frame. And like, yeah. And so what we want to do is basically map this angle, right? So this is the one that we're trying to snap to. Our head's like this, we want to snap here. Essentially what we're going to do is kind of map this whole sector onto essentially a straight line. So it's like, if you can picture like you're getting this and you're kind of mapping it onto like a plane, like onto a straight line, which is like your screen. And so this is your screen, right? And you essentially want to take, so if we take this example, right? Essentially what this looks like is this, right? This angle right here, if you can kind of picture it, sorry, I'm using like a lot of hand wavy terms and stuff, but essentially you kind of want to, if you can picture taking these two down and putting them on the side here and kind of stretching out the bottom right here and like kind of flattening out this curve. And this sector right here is going to look like this. Yeah, it kind of corresponds there. And so the idea is that you move your mouse, moving your mouse from this point to this point will essentially rotate your camera from this point to this point and snap your head to that target right there. And so those are just a bunch of mappings that you essentially go through in order to get from this stage to this stage. If you want to talk about it in more detail, I'm more than willing to. But I don't want to go into it right now. But so yeah, that's essentially what we're doing.
Okay, so we talked about how to, I guess, hack and implement hacks. But from a game design perspective, what are some ways that games prevent hacks? Right? How do anti-cheats work? And so hackers are primarily a concern when it comes to multiplayer games with servers where players can get a competitive advantage. And basically, the rule of thumb when it comes to development is never trust the client. Don't trust what they're doing, what they're saying back to you, the information that they're reporting. You're probably going to get abused if you're a game developer. Yeah, but that doesn't always work, right? Because in multiplayer games, right, there's especially in shooters, there's something called lag compensation, right? So what if there are two computers that maybe aren't sending frames, exactly in sync, right? What if there's some latency lag or dropped packets? That could result in potentially, unfair competitive advantage, which is not malicious at all. And so sometimes what happens is that games will use input prediction, where they will essentially, if there's let's say a computer that's not sending packets as fast as another client, the server will calculate where the player will be X amount of time, X amount of times to the future, and then send it, or X amount of frames into the future, and then send it back to the other client who's keeping in sync with the server. And so basically what that means is that from both clients' perspectives, they're reporting the same data, right? But in order to do that, the server does have to take I guess, does have to trust the client and what they're reporting to some extent. And there are ways that, input prediction systems have been broken in other games. But most anti-cheat techniques, right, revolve around using server validation for player input. So an example of this would be, right, rather than having a client report its world position, like its XYZ coordinates, we can have it report its inputs to that position, right? So an example here is like, what if I press, the W key, right, to move forward for 0.5 seconds, instead of saying, okay, the player has moved to XYZ position. What does this allow us to do? From a game developer's point of view, right, we can calculate what is feasible for a player to move an X amount of frames, right? Instead of like trusting the player is, let's say, at the coordinate 0, 0, and then suddenly like flying off into space, and we trust that, we can just say, hey, the client is reporting I pressed like W for 0.5 seconds, and then the server side can do the calculations of where the player will be based off those inputs. And another thing we can do is essentially line of sight calculations to help detect wall hacks. So we just look at we track the view angles of the player, and if they're aiming, for example, at an enemy, like perfectly tracking them behind a wall, I think it's pretty obvious that that person is probably using some sort of aim assistance. And the second thing we can do is sort of fog of war, limiting the information that's actually sent to the client. So an example would be like in MOBAs, like League of Legends or Dota. The game doesn't send the positions of all the enemies until you can see them in game. And so the general rule of thumb is if you can't see them, don't send the information to the client. If it's not in memory, then a hacker can't use it. Some other methods are asset validation. So essentially running a checksum on all the code right before the game is launched to see if anything has been modified or has been running. Really, I guess, pretty popular example of this would be like Valorant Vanguard system, which uses aggressive kernel level monitoring. What does that mean? Josh and Jeff alluded to, like, with an external hack, there'll be a lot of system calls that happen, right? Essentially what that means is like we're asking the operating system to give us some permission, right? Whether it's like allocating memory, right? Or drawing something at the in the screen. Essentially, we can look at from the perspective of the kernel all the system calls that are made to the game's process and decipher, hey, is this a valid system call? Is something that we expect? If not, we can remediate on that. Second thing is like human replay review. Example would be CSGO's Overwatch system. So it turns out, players, especially good players, can spot hackers pretty easily. Like it's pretty easy to tell that Jeff was, aimbotting and that just from, just the naked eye. So we can, I guess some companies have actually taken this further and applied like machine learning to it. So Valve applies data from these human replay review systems to train models that are pretty accurate in detecting cheaters.
Yeah, so now here's when you can start messing around with stuff. So hopefully you've downloaded Visual Studio and Cheat Engine by now. And so for our challenge, we also have a Unity game where you can make your own aimbot for. So DN5 and Mono will be very useful for that. And this presentation is basically over. Yep. All right. Thanks for coming.